This lab is meant to explore constant velocity and how objects which appear to move constantly actually have unseen and unknown forces acting upon them. We use Tracker to observe the motion of an object, and then we compare that to our computer model of the same velocity. Now, we base this model on our fundamental principles, which is Newton's second law, which is this function right here, or this equation right here. To find the final velocity, you take the initial velocity and then add that to the net force over the mass times delta t, which is your change in time. And for our purposes, because it's going to be constant velocity, we're actually going to have a net force of 0, and it'll be just the same velocity throughout. And then to find the position, you take the initial position and add that to the velocity times the change in time, delta t. Now, the object that I used was a can rolling across a desk. I used this 8.5 by 11 inch sheet of paper as my scale, and then I set my axes so the origin was at the can's starting location. If I had flipped my axes, the can actually would have been moving in a negative direction, which would have given us negative vectors for velocity. You can see the can just kind of moves across the screen. And this is our computational model. We take the object's initial velocity, and then I found that it had a velocity of 0.023 meters per second. To find this, I took the final position minus the initial position, and then divide that over the change in time, which was 2.7 seconds. Our force net should be 0 because it's constant velocity, and then this is Newton's second law, as we looked at earlier, as the position function that we also looked at earlier. And when you run the function, you get a graph as so. And that graph corresponds directly to our graph in Excel. This is the observed and the modeled on the same graph here. As you can see, the observed actually has a slight curve to it and doesn't quite match the model position. This is because that we find that our motion actually wasn't constant. Our velocity wasn't constant. We had changes in velocity throughout it. Now the forces that could cause this friction, if the surface was on an incline, you'll see is probably why we saw this. We don't know what forces actually add up to give us this non-zero net force. So it's really just unknown, but we do know that it is non-zero because of the change in velocity. We also have some small discrepancies in this where you kind of see it didn't move. That's probably due to slight shaking of the video or other small mistakes in calculating and finding the observed. Now in conclusion, we found that just because an object appears to have a constant velocity, there are often other forces like friction acting upon the object that affect its motion.